Right. Hey, ladies and gentlemen, this is Miss Humbert here, and today we're going to be doing Unit 2, Notes 2. So we're going to be talking about graphing systems of inequalities. So you worked on graphing inequalities, just graphing systems yesterday, so now we're going to add that inequalities element to it, which is really a combination of yesterday and what you did with inequalities on Notes 5 of Unit 1. So let's just take a look of systems of linear equations. So a system of linear equations is a set of two or more inequalities on the same graph. So we're going to put two inequalities on the same graph. And then the solution is the region that both of those solutions are going to be shaded. Okay, so that's the biggest thing we're looking for, is we're looking for where those inequalities are going to overlap. So let's go ahead and let's take a look at number 1. So we're going to go ahead and think back to Unit 1. Well, I noticed that the alligator's facing away from the Y, so I know I need to shade down. I also noticed that there's no line underneath, so I need to have a dashed line. So we're crossing the Y-axis at 1. There. And then we're going down 1, right 1, down 1, right 1, down 1, right 1. And we're going to have a dashed line through that. And then we're going to shade down from the graph. So I'm going to pick a spot on the line and go down. So I'm shading down from there. Now sometimes when students do these, I like to use different colors because it helps me kind of see where the overlap is. So taking a look at that second equation, I noticed that there we have it facing away from the Y again, so we're going to be shading down, but there is a line underneath it, so it's going to be a solid line. So we're crossing the Y-axis at 3, and then we're going up 2 over 1, up 2 over 1, and that's going to have a solid line connecting it. Hopefully yours is, better placed than mine there. There. So then what we're going to do is we're going to shade underneath. So I'm going to pick a spot and I'm going to shade underneath. So I notice that the spot where both of them overlapped is right here. So I'm going to make sure I shade that in so it's really obvious. The more obvious you make on the test and the less I have to think about it, the easier it will be for me to grade and give you the best score possible. So let's go ahead and let's take a look at number 2. So for the first one, I notice there's no line underneath, so it's going to be a dashed line, and it's facing towards the Y, so I'm going to shade up. So I'm crossing the Y-axis at 1, and then I'm going up 1 over 1, up 1 over 1, up 1 over 1. And that's going to be dashed. So from that line, I'm going to shade up. So I'm just going to go ahead and shade that in very lightly. Again, if you just have a pencil, that's cool. Just pay attention to where you're shading. So then what I'm going to do is I'm going to graph this next one. So I notice it's facing away from the Y, so I'm going to shade down. And then I notice that there's no line underneath. So again, it's going to be dashed. So I'm crossing the Y-axis at 3, and then I'm going up 1 over 1, up 1 over 1. So that's going to be a dashed line. Okay, and then I'm going to go ahead and shade down from there. So what I notice is that at no point do my two colors cross. They don't cross at all. So that means that there is no solution, which you can just write as NS. So the answer to number 2 is no solution. So on the first notes of this unit, you had to come up with an actual point. In this case, we're getting a shaded region that represents a solution or a bunch of points. So that's why we're not naming a specific point. Now, in order for us to do number 3, we need to solve each one of these for y. So let's start with this one. So I'm going to start by subtracting 3y to both sides. So then I get that, and then I get negative 3x plus 6. So now in order to solve for y, I need to divide both sides by negative 1. Well, since I'm dividing by a negative, I know I'm going to need to flip that sign. So it's going to become y, and then I'm going to flip the sign this way, is less than 3x, and then 6 divided by negative 1 is negative 6. So that's the graph for that first one. That's what we're going to graph. Let's go ahead and let's start with that. So we're crossing the y-axis at negative 6, which is right here. Then we're going up 3 and over 1, up 3 and over 1. So that's going to be dashed. Okay. So then I'm noticing that at the very end, my alligator's facing away from the y, so I'm going to be shading down. So let's just take a look at another color. So let's do blue, and let's do number the second one there. So in order for me to solve for y, all I actually have to do is subtract 2x from both sides. So I end up getting y is less than or equal to a negative 2x plus 4. I didn't have to do any changing of the symbols there. So I'm crossing the y-axis at 4. And then I'm going down 2, right 1, down 2, right 1. So I'm going to have a solid line here because there's a solid line underneath that inequality. And I notice that the alligator is facing away from the y, so I'm going to shade down. So then I'm going to go ahead and I'm going to fill that in and make sure it's really obvious that that's where my solution is. Okay, so x is less than or equal to 3. So this can get kind of confusing. So when it's just x, we're going to have a vertical line. So what I'm going to do is I'm going to find x on the y-axis. Oh, hello. Hello, typing. So then I'm going to have a vertical line through x. Okay, through that x. So now what I need to do is I need to go less than 3. So I can just look at the x-axis as kind of a number line. So when is it getting less? Well, that's to the left of 3. Okay, so let's go ahead now and let's take a look at this second one. Now, in order for us to graph it, we need to subtract x from both sides, so it solves for y. So then we end up getting that y is greater than a negative x plus 2. Okay, so let's go ahead and graph that. So we're crossing the y-axis at 2, and then we're going down 1, right 1, down 1, right 1. Now that one is going to be a dashed line, and the alligator is opening towards the y, so we're going to shade up. So our shaded region ends up being right here. Okay, so next, let's go ahead and let's take a look at number 5. I almost said 4. Number 5. So now I have that y is greater than 3. So since it's just a y, it's going to be a horizontal line. So I'm going to locate 3 on the y-axis. So when I locate 3 on the y-axis, I'm going to draw a dashed line through 3 since there's no line underneath that alligator. Then it's opening towards the y, so I need to figure out where y is getting bigger. Is it getting bigger above or below that line? And it's actually getting bigger above. So I'm going to shade in above right there. Next, let's take a look at this next one. So that one's already in intercept for us, or a slope-intercept form. Sorry, Mr. Pickens just posted about Chipotle and I saw it. I know, big things. So we're crossing the y-axis at 4. Okay, so then our slope is -1. So I'm going down 1, right 1, down 1, right 1. So again, it's going to be a dashed line because there's no line underneath there. And then my my alligator is opening towards my y, so I'm going to shade up. So then right in here is our shaded solution. Again, always making that darker so it's easy to see. Number 6 hopefully shouldn't be too bad because, again, it's already in slope-intercept form for us. So we're crossing the y-axis at 2. And then my slope is 2 or 2 over 1. So I'm going up 2 over 1, up 2 over 1. So then going down there, I'm going to have a dashed line like so. So then I noticed that my alligator is facing away from the y. So for that first one, I'm going to shade down. Now, let's take a look at that second one. So we're crossing the y-axis at a -3. So I'm going to put a -3 right there. And then my slope is a -1. So I'm going down 1, right 1, down 1, right 1, down 1, right 1. That's going to be a solid line going through there since the line itself has the inequality has the solid line underneath it. Then it's opening towards the y, so I'm going to shade up. So this right here represents my solution for number 6. Now, let's take a look at number 7. So this is a word problem. So it seems scary, but it's actually not so bad. So it says the most Jack can spend on bagels and muffins for the cross-country team is $28. A package of 6 bagels, so I'm going to let X represent bagels, costs $2.50. A package of muffins, I'm going to call that Y, costs $3.50 and contains 8 muffins. He needs to buy at least 12 bagels and 24 muffins. So let's go ahead and let's start figuring some of this stuff out. So I'm just going to move these down here so I have some space to write. So first thing we need to do is graph the region. Well, first we need an equation, right? Okay, well, I know I only have $28 to spend. So for every X thing of 6 bagels, I end up paying $2.50, which we can just write as 2.5. Then for every Y thing of muffins, it costs me $3.50, or I can just write 3.5. Then we need that to be less than or equal to 28. Now remember that when you are budgeting, you always want to have less than that amount. You cannot spend more than that. So I need to solve for y. So the first thing I'm going to do is subtract 2.5x over to the other side. Okay, so then I get 3.5y is less than or equal to negative 2.5x plus 28. Then we're going to go ahead and divide both sides by 3.5. So I end up getting y is less than or equal to, so negative 2.5 divided by 3.5 is going to give me 0.714x. And we'll talk about how to graph that in a second. 28 divided by 3.5 is going to give me 8. Okay, so let's go ahead and graph that. So we're crossing the y-axis at 8. So we're going 1, 2, 3, 4, 5, 6, 7, 8. So 8 is here. Then we're going down, I forgot my negative, 7.4. So I'm going to go almost all the way to 1 and over. So I'm going just not quite 1. If it'll let me actually do it. Okay, so that's going to be a solid line. And then I'm going to go ahead and I'm going to shade underneath that. So that's that first equation. We're actually going to end up having 3 equations for this one. So now we need to figure out how many muffins and bagels we need to get. So it says here that he wants to have at least 12 bagels. So that means that if he had more bagels, he would be a very happy cross-country member. So he needs to have at least 12. For every X package of bagels, we're going to get 6 of them. And that's for that $2.50 cost. So what we're going to do is we're going to go ahead and divide both sides by 6x. So then I get that x is greater than or equal to 2. So now I'm going to find 2 on the x-axis, which is right here. Remember, x is always the horizontal one. And I'm going to draw a vertical line that is solid. And I want at least that. So I'm actually going to the left of that. So I'm going that way with it. Okay, so I already see one of my crossings. So now we need to figure out how many muffin things we can get, okay? So it contains at least 8, or contains 8 muffins for every Y package, and we want to have at least 24, which means if we had more, that would be great. So we're going to divide both sides by 8, and we're going to get Y is greater than or equal to 3. So now what I'm going to do is I'm going to find 3 on the Y-axis, which is right here. And I'm going to have a horizontal line that's solid. And I'm going to shade up from there. So now the region that it overlaps in, let's just shade that. So it's kind of hard to see, but this right here with our bounds is our shaded region. So in order for us to get, it asks us then to give an example of a solution. So all we need to do is find a point that's going to exist in that blue triangle I just drew. So let's go ahead and let's just draw a point. Right there, let's say. So let's go ahead and let's figure out what that point is. So we're going over 1, 2, 3. And up 1, 2, 3, 4. So we went over 3, so that means we could get 3 bagels, and then I went up 4. And when I say 3 bagels, I mean 3 containers of 6 bagels. And then I said I could go up 4 and get 4 things of muffins. So that's one way he could satisfy all of those conditions. And that's what each of those solutions represent, a specific answer to what you're working on. So let's go ahead and let's take a look at this number 8. It says Rondell makes $10 per hour cutting grass. So I'm going to let X represent the hours he cuts grass. And $12 an hour for raking leaves. I'm going to let Y represent the number of hours he spends raking leaves. He cannot work more than $15 a week. Graph 2 inequalities that represent that Rondell can use to determine how many hours he needs to work each job if he wants to earn at least 120 hours per week. So let's start and let's just make an equation that simply represents the number of hours. Okay, so he cannot make more than 15 or he cannot work more than 15 hours a week. So that means his hours cutting grass and his hours raking leaves need to be less than or equal to 15 because he could work exactly 15. So I'm going to go ahead and subtract x from both sides. So then I get y is less than or equal to negative x plus 15. So let's go ahead and graph that. So we're crossing the y-axis at 15. So it's 3, 6, 9, 12. Here's 15 right here. And then I'm going down 1, right one, down one, right one. And it's going to be a solid line. So I know I cannot work, and apparently what is that? Like fairy dust? Okay, so I can't do more than that. So I'm going to shade down. Okay, so then what we're going to do is we are going to do the next one. So now we're going to focus on how much money he can, so we're going to kind of focus on the money. We're going to have a money parenthesis. So he wants to earn at least $120 a week. So that means if he makes more, that would be better. So we're going to use that symbol because he might want to make more. For every X hour he cuts grass, he gets $10. For every Y hour he rakes leaves, he gets 12 hours. Now that looks like a G. Cool. So I need to solve this for Y. So I'm going to go ahead and subtract 10x from both sides. So I'm going to get 12y is less than or equal to negative 10x plus 120. So now I'm going to divide both sides by 12. That is the worst 2 I think I've ever drawn. Okay, so then I get y here. So negative 10 over 12, I'm going to actually reduce that fraction. Since they're both divisible by 2, I'm going to write that as negative 5 over 6. Fractions are a lot easier to graph when we're talking about slope rather than decimals. And then 120 divided by 12 is just going to give me 10. Okay, so I'm crossing the y-axis at 10. So I have 2, 4, 6, 8. So here's 10. And then I'm going down 5 and over 6. Which is here. So I'm going to go ahead and draw that. So then I'm going to shade up from that because that represents the amount of money I would also like to make. So now I want to shade in what's in between here because what's in between here represents me still making the money I want but limiting the number of hours that I work to make sure that is acceptable as well. Okay, so that's your final answer for number 8. So let's take a look at some more challenging graph problems, okay? So what we want to do is we want to graph these 3 systems. So first of all, let's graph x is greater than 0. So we're going to find 0 on the x-axis, and that's actually just at the origin. Remember when it's just x, we're going to have a, highlighted apparently, horizontal line. And it's going to be solid because of that solid line underneath the inequality. Now, x is getting bigger as you go to the right. So I'm going to go ahead and just shade that into the right. Problems like these is where having different colors really comes in handy. So then I am going to solve this for y. So I'm going to start by subtracting x from both sides. So I get 2y is less than or equal to negative x plus 2. So if you're not sure how I got that x over to the other side, definitely come let me know. I'm more than happy to work with you. So then I'm going to divide both sides by a negative 2. Now when I do that, I need to make sure I flip the symbol because I divided by a negative number. Negative x divided by 2 is going to be a positive 1/2 x. 2 divided by negative 2 is going to give me a negative 1. So now we're going to go ahead and graph this final answer here. So we're crossing the y-axis at negative 1. And then I'm going up 1 over 2, up 1 over 2. Since there's a line underneath that inequality, I'm going to have a solid line. And then I'm going to shade up from there. Okay? So now that we did that one, let's go ahead and let's take a look at this final inequality. And we're going to graph and see where it overlaps. Okay? So let's do that and let's start by bringing that 3x over to the other side. Okay, so then I have 4y is less than or equal to a negative 3x plus 12. So now I'm going to subtract 4 from both sides so I can get that y completely by itself. So then I get y is less than or equal to negative 3x divided by 4. Well, I'm going to write that as the fraction negative 3/4 x. And then 12 divided by 4 is going to give me 3. So that means my y-intercept is 3. So I'm crossing the y-axis at 3. So I'm just going to go ahead and plot that point. Then I'm going to go down 3 and right 4. Down 3 and right 4. So I'm going to connect those again with a solid line. Since the alligator is facing away from the y, I'm going to shade down. So I noticed that I kind of made a triangle. All 3 of my colors overlapped in this little triangular region right here. So you really, really want to make sure it's obvious where your solution is, especially when it can get kind of messy like this one here. So let's take a look at our final problem. I promise you it is a lot more scary than it, or a lot less scary than it looks. I'll bring this guy down here. So let's go ahead and let's take a look at this. So first we have x is less than 2. So I'm going to go ahead and find 2 on the x-axis, and I'm going to draw a dotted vertical line through it. If it's just x, it's a vertical line, and since there's no line underneath it, we need to have that dashed line. Less than 2, well, it's going to be less than going to the left, so I'm just going to shade it out this way. Notice I shade lightly when I do each individual line, so that way when I make it solid, it makes more sense. So y is greater than 1/4 x. So we're crossing the y-axis at 0, and then we're going up 1 over 4, up 1 over 4. So that's going to be a dashed line. So since there wasn't anything added on here, that means that my y-intercept is 0. So I'm going to get a plus 0. So now, since I'm going up 1 over 4, I notice that my inequality is facing towards the y. So I need to shade up. Or I could just move my graph and just lose everything, because that's also super enjoyable as well. So then we're going to shade up. So let's go ahead and let's take a look at this next one. So we're crossing the y-axis at 9, which is just slightly off my graph, so I'm just going to plot it right there. And then I can't go up 2 and over 1 because that's going to be way off my graph. So here's a hint. Down 2 and left 1 is also the same as going up. Okay? So then I'm going to have a dashed line for that one as well. Now it's facing towards the y, so I'm going to shade up. So right now it looks like that upper left-hand corner is kind of where everything is going to fall. So next, what we're going to do is we are going to solve this last equation for y. So I'm going to start by subtracting x from both sides, and then I get 3y is less than a negative x plus 9. Divide both sides by 3. And then I get y is less than, so I'm going to write that as a negative 1/3 x. Since there's nothing on top, you could write negative x over 3, but I like to write negative 1/3 just so I know that it's there. And then 9 divided by 3 is 3. So I'm crossing the y-axis at 3, and then I'm going down 1, right 3, down 1, right 3. And it's going to be dashed again. And then I'm going to shade down. And I'm not shading all the way because really all I'm caring about is that overlap. So I finally found my overlap of all of them. So I need to shade that in a lot darker. So I'm going to just do a bright red here. And we're going to shade in this to make it really obvious that this right here is my solution to all of that. Okay? So that concludes your note video for today. Thank you for listening.